Yeah. So, hi everyone. It's me and Nelson again, and this time we are covering chapters 25 and 26, which are the last two chapters in the meta programming section of Eloquent Ruby. That's part 3 of the book. So I'll be doing a bit of screen sharing so that you can follow along.
I don't see anything yet.
It's not yet sharing. Let me see. Let me see. Yeah, I
Okay.
think it is right now.
Yeah.
Yeah? Yeah, so last week we covered chapters 23 and 24. And chapter 23 was about method missing, and chapter 24 introduced, or maybe talked about in more depth, the concept of monkey patching. And this is what we are going to build upon, still the monkey patching concept, and it will continue all the way into chapter 26. So we'll start with chapter 25, and I'm going to quote the code on page 306 at the start. So open classes again. So far we've seen how you can change a Ruby class definition by simply repeating the class definition. If the widget class is already defined and you come back a second time to say class widget, then your widgets are going to change. Something we rather took for granted in that discussion was the question of how classes get defined in the first place. So on page 306 at the start, at the very top of the page, we have a class. The name of the class is mostly empty. So if we were to type out this code in the Ruby interpreter or IRB, and then we press enter, we would have the output of hello from inside the class. Because inside the class we have a put statement, and the put statement inside the put statement is associated with a string, and the string is hello from inside the class. So when we press enter, we are going to have this string returned to us. And what does this mean? This means that Ruby classes are executable. That is the very first takeaway from this chapter. The fact that you can define a class, and inside that class you have a put statement, and then when you press enter or when you execute, you're going to have that string returned to you that tells you that classes in Ruby are executable. And this is not limited to just you having a string inside the class. You can also have methods. You can also have if statements that check whether something is true or false and return to you output accordingly. So regardless of whatever is inside the class, you will get output depending on that, and that tells you that classes in Ruby are executable. So this quoting from the book, along with the output and the nearly mostly empty class, we can pull something very important from this little demonstration, that Ruby class definitions are executable. The put statement went off because when the Ruby interpreter hits a class declaration, because remember we declare a class by using the class keyword. So when the Ruby interpreter hits a class declaration, it executes the code between the class and the end, which in our case is the put statement, which the put statement associated with the string hello from inside the class. And on to another key takeaway from this chapter. Inside the class we've defined, the mostly empty class, we have a string, and we are outputting that string with the puts. I don't know if I should call it a method or a keyword, but inside the class, we can check for what the current value of self is, and we are going to find out that for a call inside the class, at any one point the value of self is the class itself. And as you can see, this code class mostly empty, and inside we have a put statement, and we're trying to see what the value of self is. So you're going to have I think this is an object, and it is showing you that the current value of self is the class, which is mostly empty. And this is the second takeaway. We can use this little discovery to prove something you've been told but perhaps have never really seen before your eyes. The value of self inside the class definition is the class that you are defining. And this is something we are going to something we are going to expound upon in chapter 26. It will come in very, very handy when we are dealing with some of the code we'll look at in that chapter. So continuing to another class now, we have a class named lessEmpty. And inside this class, we pretty print, pp means pretty print. And then we call the instance methods, which is defined for every class. And we give it an argument of false. What the instance method helps us to do is that when we call it inside the class, for example, the lessEmpty class, we are going to have, at the point at which it's been called, we are going to have output that tells us the instance methods that are defined for that class. And when we pass in this argument false instead of true, when we pass in false, like you've seen in this code, the code inside the lessEmpty class, this tells us that you should return output for only instance methods that are defined inside the class, like instance methods that are explicitly defined inside the class, excluding any instance methods that could be inherited from a superclass or a module. That is the importance of the false argument we pass in here. So after the pretty print, the first call of the instance methods with the false argument, we now define an instance method named do something. And then after, we call the instance methods again, still with the argument false, to tell us, to show that we only want you to tell us or to return to us the instance methods that are explicitly defined inside the lessEmpty class. For example, this do something method. So on to the output. This is now page 307. The output, we are going to have two sets of output. For the first call of the instance methods class, the instance methods method, we are going to have an empty array. Because remember, when we call the instance methods method at the top of the lessEmpty class, we call it before we've defined any instance method in that class. So basically, the lessEmpty class doesn't have any instance method inside it at the point when we call the very first instance methods method, which is why you get the empty array. Then following that, we define the method, in this case the do something method, and then we call the instance methods method again. So we see our second output, which is that we have an array, and inside that array we have a symbol. The symbol is named do something, which basically means that you have one instance method defined in the lessEmpty class, and the name of that instance method is the do something method. So that is pretty much it. We are trying to see, does this class have any instance methods defined for it? And while doing this, we are excluding any instance methods that could be inherited from either the superclass or any module that's mixed into any other class. And as you see, based on the output, yeah, you can figure out the instance methods defined within your class. And now we look at something we first saw in, I think, chapter 20, either 23 or 24. So we have this class, and the name of the class is the same method twice. So we define a method named do something, and inside it we have a string named first version. And then after that definition, we define another method of the same name. So we have two do something methods. One is returning to us the first version, or a string named first version, and then the other one is returning to us a string named second version. So when we come here, page 308 at the very top, we create a new instance of the same method twice class. And then the name of that instance is twice. So when we call the do something method on this instance of the same method twice class, specifically the twice instance, our output is going to be the string second version instead of the string first version. And why is this the case? This is because when we defined the do something method for the second time and provided the string second version inside it, we basically, I want to call it, we overridden the very first definition of the do something method, and this second method, okay, they're confusing because it's the same name, but the second definition of the do something method will take precedence over the first definition, and that is why we end up with the string second version instead of first version. And now the code
Can
we've looked at. Yes,
can
yes,
I
Nelson.
say something? Yeah.
Okay.
So um, yeah, the last version will be the one that's used. Um, but they're making something explicit here. There. So in other languages, there's this concept of overloading, method overloading, which means that as long as the parameters are different, two methods with the same name can exist. So if the first method says do something and it takes no arguments, and the second method is do nothing and it takes in a string or an integer, the if as long as the signature of the method is different, in other languages it's okay and both versions can exist. But in Ruby, that's not the case. There's no concept of method overloading. There's the only way it works in Ruby is to override. So even if the function signatures were different, like you passed a different thing into do something, it's still going to override it. That's all I wanted to say.
Okay. So yeah, I think that really explains that the code at the very bottom of page 307. And like you can see on page 308, we can define a class, and in this case the name of the class is the same method twice. We define class, and then we write the first definition of the do something method, and then we close the class with the end keyword. After that, we reopen the class again, and then we write a second version of the do something method. And then this opening the class again and then closing it, and redefining a method we had previously defined. This is a classic example of monkey patching. And yeah, so that is pretty much it when it comes to that section. So we proceed to the section of put programming logic in your classes. So we in this section we have a problem. We want to we let me just read from the book. We might imagine that all the applications using a document class wants to be able to save their documents to a file, but only some of those applications need to encrypt the documents as they are saved. If there was a constant that turned the encryption off and on, then it's fairly easy to build a class that configures itself accordingly. So here we have all documents. Like when you're working with a document, at the end of the day, you want to be able to save this document. But then when you save the document, some documents are private for some people or for some organizations. So you limit their access and you make it such that not everyone can access the content of this document. And that is the problem we have here. We want to encrypt. Now let's say I have a string and the string is ABC and I want to encrypt that string. I think when I encrypt that string, I'll have like the order being changed from ABC to something like, let's say, CBA or BCA. And that jumbling of the order of the letters is what we refer to as encryption. So you want to check whether is should this document be encrypted such that we limit its access. If that is true, then we are going to encrypt the content of the document. Otherwise, we are not going to encrypt that document. And then the code on page 309, we see like a visual representation of this problem in code. So we have a save method. This is an instance method. And then we have an if statement. And this if statement checks for the presence of encryption enabled. Encryption enabled is a constant that you're going to define prior. For example, you can say encryption enabled is equal to true, or you can assign it to false. So if encryption enabled is equal to true, you're going to encrypt the string. And in this case, when you look at the the save method is utilizing either because remember we have two encrypts method. One does the actual encryption and then the other doesn't. So depending on whether the document needs to be encrypted or not, and whether encryption enabled, the constant encryption enabled is evaluates to true, the save method, inside the save method, we are going to be utilizing the encrypt method that is suitable for our use case, and then we end up saving the file accordingly. So what do I mean by this? Let's take a case whereby encryption enabled is set to true. So if encryption enabled is set to true, we are going to be calling the first encrypt method, the first encrypt instance method, which is defined inside the first if statement. And then if encryption enabled is set to false, we'll be using the encrypt method that is defined after the else keyword. And that is pretty much it. Like that is one way of solving the problem. And then we try to use some of the concepts we've learned here that relate to class methods to come up with a more elegant solution to the same problem. And that is what the next section talks about. So here, this is page 310. We specify the constant encryption enabled to be equal to true. And then inside the document class, we create a class method called enable encryption. And when you see self here, self refers to the actual document, the actual document class, which means that we can call this method on the actual the class itself as opposed to an instance of the class. So inside here we have a class method to be specific, and this class method is called enable encryption. So here it takes an argument of enabled, and if we've enabled encryption, if we've enabled the encryption, we are going to encrypt. If we've not enabled the encryption, or the encryption is not needed for that specific document, then we don't encrypt. And then at the very bottom, after we close off the enable encryption class method, we call the method and we say enable encryption, and then we pass in encryption enabled. But remember, at the very top, of the page, we defined the encryption enabled constant to be equal to true. So this is basically similar to us saying enable encryption and then we pass in true. So for this case, we are going to actually be doing the encryption and we'll be using the encrypt string method that is just after the if statement keyword. So for that specific document, we'll be encrypting. And then you can also turn off the encryption, because remember this enable encryption method is a class method. So you can call it on document itself, and then you say document that enable encryption false. And in this case, we'll default to the second encrypt string method, which basically doesn't encrypt anything. It doesn't do anything for that specific document. So in the wild, now, in the wild, let me try to read. Executable class definitions are wonderfully useful when you need to write code that will work in different environments. Take the transition that the Ruby world is going through right now from Ruby version 1.8 to version 1.9. Progress is a great thing, but it can also be a pain in the neck. It's great that version 1.9 adds all sorts of new methods to the built-in classes, but what if you need to write code that will run in both Ruby versions? So the problem here is we have a name. We have a name, a variable called name, and we've assigned it to a string, and the string is Robert Jordan. So we are trying to get the character at index number 2 or at position number 2. And in Ruby 1.9, you can see that you can call name and then you open the square brackets and then you put 2 to denote that you need the character at position number 2 or at index number 2. And for the case of Ruby 1.9, you're going to evaluate to a string containing one character, in this case, B. But for Ruby 1.8, when you do the same thing, you're going to have the value as 98. And how do we make it such that the program can check whether it's Ruby, whether the current version is Ruby version 1.8 and do the needful, or when it's Ruby version 1.9 and still do the needful? And this is where the solution comes in. So inside here, we inside the document class for the Ruby version 1.9, we create a method. The method is char underscore art, and then it takes an argument of the index. Because remember here we are specifying the index so that we get the character at that index. So we have the content instance variable, and then we pass in the index. Then for the Ruby version 1.8, we still have the same method, but then instead of ending at passing in the index in the square brackets, we have to add a chr method. And now when you look at page 312, we see that we can use if statements to check for the Ruby version, because Ruby version is a constant, so you can use it. It's a Ruby constant that you can use to check which version of Ruby you're currently running at any point. So you can say if the Ruby version is greater than or equal to 1.9, you just call the instance variable at content and then you pass in the index. And then you also say else, and then else is if, for example, the Ruby version is 1.8, you're going to say at content, you pass in the index, and then you also call the chr method at the end. And what are we trying to see here? What are we trying to achieve here? We are trying to get the same output for this operation regardless of the Ruby version we are running. Yeah, I think that's it. Nelson, do you have anything you want to say?
Um, just that this is all very, very new to me. I haven't done this before. I'm learning a lot from these meta programming chapters.
Yes, me, it's even confusing for me, but I guess it will come around with time.
I don't think it's anything that you really need to use as when you're just getting started with the languages. I mean, there's so many other fundamental programming things that will get you really, really far. These are more advanced concepts that you only need in rare cases. This isn't how you would program day to day. This is just how you would program were if you had very specific use cases.
Yeah. So now we have another part of in the wild, another example. So the problem is, no, actually, let me first give a backstory. So when you're programming with Rails, you type Rails S in the terminal and the server starts. So most of the time when you make changes inside the app, you can see those changes. You can see the result of those changes inside the browser without having to restart the server. Of course, with a few exceptions. Now, like let's say if you're working with Tailwind, you'll have to stop the server, rebuild the assets, and then restart the server again. But for other cases, you can see the changes on the fly, and this is what the author builds upon to show us how we can implement such a similar thing for the document class. So the aim here is to make the document class reloadable, such that if we make changes to any methods inside the document class. Now let's say if we remove any instance method that was previously defined inside the document class, on reloading the file, we won't have that instance method show up, and he presents a solution. So inside the document class, we create a class method called reload. And inside that class method, we call the load method, and we pass in the file path, the path of the file, as the argument. So the next part on page 313 tells you that load is kind of similar to require, but the difference between the two is that require keeps track of the files that were initially loaded so that it doesn't load them again. But load, or the load method, on the other hand, reloads everything all over again. Whether it was reloaded before, whether the file was reloaded before, it doesn't care. It just reloads everything at once when it's called. And the conclusion is that load, or the load method, is a more primitive version of the require method. And then, like we've said, we are trying to make sure that if we make changes, the goal is to make sure that if we make changes to the document class, we don't have any other, when we load the file, we are not going to see things that were removed appearing after loading the file. Now, for example, the instance methods. And this is what we look at here. This is the code at the bottom of page 313. So we kind of modify the reload method to manually remove the instance methods that are removed at any one point so that they don't appear when we reload the file. And to do this, we create still another class method called remove instance methods. And this class method will be associated with performing the actual removing, such that inside the reload class method, we call the remove instances methods, which is a class method. We first call it. After calling it, we are going to remove all the instance methods, and then we are going to reload the file, which means that given that we've first called the remove instance methods method, we are not going to see any instance methods that were removed after loading the file. And yeah, that is pretty much it. So, staying out of trouble. Let's face it, when there is code, there will be bugs. write enough of the kind of class level logic discussed in this chapter, and eventually you'll make all the traditional boneheaded mistakes that have plagued engineers since the first Hello World. The difference is that the same old mistakes can have interesting consequences when they occur in the middle of making structure changes to your classes. For example, take a look at this broken version of our encrypting document class. So when you look at this code is broken in that it doesn't call the enable encryption method, because remember, at the very bottom, after defining the enable encryption class method before, we called that method and we passed in the constant encryption enabled, which is defined at the very top. But here we leave out that call to that method. And because we've left out that call to that method, this code is broken in that it won't work, it won't achieve, it won't do what it's supposed to do. Same goes for the code here on page 315. It is also broken in that now let's say the person that was writing this code, instead of spelling encrypt starting with an E, he spelled encrypt starting with an I. So this code is also broken. What's the key takeaway here? Tests. Tests. And that is why he says that the moral here is simple and it's called RSpec. For those that don't know, RSpec is a testing framework that you can use to write tests for your programs. And he says that here you have two tests. One says it should encrypt if the encryption is enabled, and the other test says it should not encrypt if the encryption is disabled. So if you have the code above which is defective and you run these tests are going to fail. And this will tell you that the code you've written has issues, and then you'll have to work throughout those issues or solve those issues. And then after you solve the issues and you run the tests again, the tests will pass. So that's it. That's it for that chapter.
Yeah.
Yeah.
In other programming languages, the if you have a statically typed programming language, it could catch things like misspelling of a method definition, um, but it's then you wouldn't get the dynamic behavior that we were seeing here, where you're at runtime defining a different method, which you're probably not going to find in a statically typed compiled language. So the fact that we're dynamically creating these methods is very, very powerful. But yeah, there are a lot of foot guns, just like we saw in the example. It's like, oh, it's a simple misspelling, and now the application is broken. And the only way to catch it is to actually run and make sure that the method spit out the right thing. But
Yeah.
I think it's in general, that's why Ruby has a strong emphasis on testing, and it's because it's so dynamic, and you don't have the guardrails of static typing, that you absolutely positively need those tests to tell you whether or not your code is okay, or if some change that you made broke some other piece of code that you wrote.
Yeah. So I think Nelson, we should start another meeting
Yeah.
because this is about to end.